want you to imagine a very specific scene for a second. You are walking into this massive state-of-the-art embassy. The architecture is just absolutely stunning, right? It's built to withstand pretty much anything. Security is totally flawless. And you walk into the main assembly hall, and it is fully furnished.
Completely ready to go.
Exactly. We're talking plush leather chairs, heavy mahogany desks, and these shiny little nameplates sitting on every single desk, meticulously arranged. But as you look around, listening to the echo of your own footsteps, you realize there's absolutely no one there. The building is completely empty.
It's a really striking image, a multi-billion-dollar piece of infrastructure just sitting there like a ghost town, seemingly abandoned before it was even used.
And that image, that beautifully constructed but totally empty embassy, is basically the framework for today's deep dive. We are exploring the hidden architecture of global finance, and specifically, we are pointing a microscope at the XRP Ledger, commonly known as the XRPL. We've got a fascinating stack of sources to pull from today. It's anchored by this really interesting Substack essay written by Janus the Watcher. It's titled XRPL, the United Nations of Liquidity, and it was published on June 3, 2026. And we're also going to dissect a really insightful subscriber comment on that essay from a reader named William Lawley.
Yeah, the mission today is to tackle this massive multi-trillion-dollar question that's currently just hanging over the entire crypto and traditional banking landscape. Because for years, the broader crypto community has looked at the XRP ledger and just dismissed it as a failed decentralized network.
Yeah, that's the standard narrative.
But we are exploring a totally different premise today. What if it isn't a failure at all? What if it was actually designed from the ground up as a pre-institutional treaty body?
A structure secretly waiting for the world's most powerful financial players to finally walk into that empty embassy and take their seats.
Exactly.
Okay, let's unpack this. Because to really understand why this network was built with such strange, unconventional rules, we first have to understand the war that's happening in global finance right now.
Yeah, there is a very real ticking clock hanging over these institutions.
There really is.
And the author points to a specific timeline laid out by McKinsey to illustrate this urgency. According to their analysis, if a coalition of financial institutions can close the interoperability gap between these various tokenized money systems by the end of 2026.
Which is right around the corner.
Exactly. If they do that, then near instant commercial bank money transition stops being this quiet backroom pilot program and actually becomes the main rail for global finance.
And the prize for controlling that main rail is insane.
Oh, it's massive. They're talking about capturing a market of roughly $4 trillion a year in tokenized deposits.
$4 trillion. At that scale, institutions stop treating blockchain technology like an experimental sandbox for tech enthusiasts, right? They start fighting aggressively over who actually owns and governs the underlying plumbing of the whole global economy.
And if we connect this to the bigger picture, you can see the heavyweights already maneuvering for control.
Yeah.
Consider the Bank for International Settlements, or the BIS.
Yeah, the central bank of central banks.
Exactly. In May of 2026, they handed their top governance roles to the central bank governors of Italy, Brazil, Australia, and Japan.
Which is highly strategic.
Extremely.
Yeah.
Brazil, for instance, is already running Ripple's settlement infrastructure on the XRPL. Japan has SBI Holdings, which is a major influential player in a completely different rival system called Canton.
So these appointments are really about securing leverage. They're setting the agenda for how all the world's digitized value is going to move.
Yeah.
That brings us perfectly to the contenders actually fighting for this $4 trillion prize. Because the market has basically split into two completely opposite extremes. Let's look at the first extreme, Canton.
So Canton represents the institutional frontrunner. Mechanically, it functions as a walled garden.
Built by Digital Asset, right?
Yep. And it's operated by a consortium of the most massive traditional financial players you can think of. We're talking Goldman Sachs, the DTCC, BNY.
So it's what we call a permission network.
Exactly. That means it is entirely closed off. It's governed exclusively by the giant institutions that use it. If you want to build on it or transact on it, you need their permission.
Wow.
And they can theoretically alter or reverse transactions if the consortium agrees to do so.
It just sounds like the old boys clubs, upgraded with cryptographic efficiency.
Basically, yeah.
But then on the other end of the spectrum, you have the federation model. The essay points to Cosmos as the prime example here.
And Cosmos operates on a completely different philosophy. Instead of one walled garden, Cosmos is a federation of sovereign, independent blockchains.
Okay, so they're separate.
Yeah, they are connected by a neutral messaging system known as IBC or inter-blockchain communication.
How does that work in practice?
It works a bit like email, honestly. Independent servers passing verified messages to one another, but the crucial friction point is that Cosmos lacks a shared foundational settlement asset underneath it all.
Let's pause on that because that mechanism is really vital.
Yeah.
Why does lacking a shared settlement asset cause so much friction when you're moving value?
Because without a highly liquid, universally accepted bridge asset, you are forced to rely on the old correspondent banking model. It's just digitized.
Oh, I see.
You have to pre-fund accounts in different currencies across different chains, or you have to hop through multiple different tokens to get to your final destination.
And you're absorbing fees and slippage at every single jump.
Exactly. The messaging is instant, but the actual settlement of value is still totally fragmented.
Which places the XRP ledger in this incredibly weird middle ground. Because when traditional crypto purists look at the XRPL, they see a network where a single company, Ripple, wrote much of the code.
Yeah.
And it doesn't fit the pure permissionless ethos of Bitcoin.
No, not at all.
So they just conclude it's a decentralized network that failed to decentralize.
Yeah.
But Janus argues that this strange architecture isn't a bug. It is an immune system that actively rejects the normal rules of crypto.
Yeah, and to understand why people assume it's broken, we really need to lift the hood and look at how the machinery actually operates, because it violates pretty much every sacred rule of traditional blockchain design.
Okay, give me an example.
Let's look at how the XRPL makes decisions to update its own code. It requires an 80% amendment consensus.
80%.
Yeah, and that supermajority must be maintained continuously over a 2-week window.
That is a staggering hurdle. The author gives a recent example, right? The fixed price Oracle order amendment. Yeah. An Oracle is just a piece of code that feeds outside data, like the price of gold or fiat currency, onto the blockchain. If that code needs a critical fix, you don't just push an update. You need 80% of the network's active validators to agree to the fix, and they can't waver for 14 straight days.
And this leads to the most controversial aspect of the network, which is who actually gets to cast those votes.
The validator list.
Yeah. The validators are drawn from a unique node list. The default list, known as the DUNL, is published and curated by Ripple and the XRP Ledger Foundation.
Okay, so it's curated.
Yes, and currently that list has roughly 35 entities on it.
Wait, 35? Which means to hit that 80% quorum, you only need about 28 of those specific validators to agree.
Exactly.
You have 28 entities deciding the fate of a multi-billion-dollar global network. But the mechanics get even stranger. Let's contrast this with the rest of the industry. In Bitcoin, miners secure the network by solving math problems, and they are rewarded with freshly minted Bitcoin and transaction fees. In Ethereum, validators lock up or stake their crypto, and they earn a yield for processing transactions. But on the XRP ledger, validators are entirely unpaid.
Furthermore, the transaction costs aren't collected and distributed to anyone.
What happens, Tim?
When a user pays the tiny fraction of a cent to send a transaction on the XRPL, that fee is literally burned. It is destroyed, slightly reducing the total supply of XRP.
So it's just gone.
Gone. The mechanism exists purely to make spamming the network incredibly expensive, but it offers zero financial reward to the people actually running the infrastructure.
Okay, I have to challenge this design from a purely logical standpoint. It's like asking a private company to maintain the world's most important electrical grid entirely out of the goodness of their hearts for free.
Yeah.
By removing the financial incentive, aren't you just guaranteeing that the system eventually degrades and breaks?
What's fascinating here is how violently the XRPL clashes with standard crypto economic theory for that exact reason.
It really does.
The traditional critique is that without a security budget, without paying your validators, attrition is inevitable. A university running a node runs out of grant money. A tech startup pivots to a new project.
And they just shut their servers down.
Exactly.
And because of how the consensus mechanism works, if the active validator count drops below the necessary threshold, the network doesn't just slow down and process transactions later.
No, it halts completely.
It is engineered to stop producing ledgers rather than risk producing conflicting ones. So a coordinated departure of even a few validators could trigger a complete global network freeze.
And when you combine that fragility with the fact that a centralized foundation is essentially curating the guest list of who gets to vote in the first place,
right.
Critics argue that the 80% consensus is little more than political theater. By traditional decentralized standards, it looks fragile and highly manipulated.
Which brings us to the absolute paradigm shift in this essay. If the lack of payment and the curated lists are such obvious, glaring flaws, why did some of the smartest cryptographers in the world design it exactly that way?
The author brings in a pivotal quote from David Schwartz, the original architect of the XRP Ledger. Schwartz argued that the best incentive is no incentive.
Meaning what exactly?
The underlying logic is that a validator with nothing to extract from the network has nothing to collude over. There is no block reward to steal and no profit motive to prioritize certain transactions over others. But the essay takes this mechanical reality a massive step further. The central thesis is that the XRPL shouldn't be analyzed as a crypto network at all.
Then what is it?
Structurally, it functions as a multilateral governance body.
Because the analogy the author uses completely reframes the entire system. Think about the United Nations General Assembly or the international Bretton Woods system established after World War II. When a sovereign nation joins the UN, they don't get a per-vote cash subsidy for participating.
Quite the opposite. They pay assessed dues. They absorb the massive operational costs of sending diplomatic delegations, maintaining a permanent presence, and participating in endless committees.
They absorb the cost because the strategic value of being in the room, the agenda-setting power, the ability to negotiate global policy, and most importantly, the veto power, is worth infinitely more to a nation-state than a small cash payout.
That's a great point. And let's apply that mechanism directly to the XRPL. By engineering a system where validators receive zero financial reward, you create a strict intentional filter. The tech startups, the yield farmers, the entities looking for short-term profit, they all leave.
Because they have no economic reason to dedicate server space and engineering time to the network.
Exactly.
So who runs a node for free? Only the entities whose massive multi-billion-dollar daily operations fundamentally rely on the network existing and functioning predictably. We are talking about central banks, the U.S. Federal Reserve, the European Central Bank, the People's Bank of China, and mega corporations using tokenized rails like Amazon for global supply chain settlement, or Apple for consumer payments.
For an entity of that scale, the server cost of running an XRPL validator node is, it's a rounding error. It is practically zero.
Literally nothing to them.
But the strategic value of holding that seat is immeasurable, entirely because of that 80% consensus rule.
Because if a coalition of central banks or massive commercial entities controls just over 20% of the vote, they hold veto power.
Yes.
They can block any radical code change, any experimental update that might threaten their trillion-dollar settlement operations. By withholding payment, the network ensures that the only people governing the settlement layer are the exact institutions relying on the settlement layer.
It was built mechanically to be a United Nations of liquidity. The reason it currently looks strange to the crypto world is that the institutional seats are currently empty. The universities and independent tech enthusiasts currently on the validator list are essentially just keeping the chairs warm until the real diplomatic delegations arrive.
But wait, if we're adopting the United Nations analogy, we have to look at how the actual United Nations operates in the real world. It is famously, disastrously gridlocked. Does the essay address the massive holes in this treaty architecture?
This raises an important question, and Janice does address it by introducing the 10th man rule. He's actively searching for the strongest objections to his own theory.
Okay, let's test those objections. Imagine a scenario where the U.S. Federal Reserve and China's central bank both claim their validator seats, giving both of them veto power over the network's code. If a critical network patch is proposed during a period of intense, real-world trade war, wouldn't they just veto each other out of spite, causing a permanent freeze?
It's definitely a risk.
You would have a global settlement layer paralyzed by geopolitical rivalries exactly when neutral settlement is most needed.
That is the geopolitical paralysis objection, which is highly similar to the gridlock we see on the UN Security Council. And to be clear, we are purely analyzing Janice's theory here without taking any political sides, but...
Just looking at the mechanics.
Exactly. But that flows naturally into the problem of bureaucratic ossification. If it requires an 80% supermajority held continuously for 2 weeks just to patch an oracle or update a cryptographic standard, the network will move at a glacial pace.
Yeah.
In traditional statecraft, moving slowly is a feature, but in the rapidly evolving landscape of financial technology, taking a decade to agree on an update means you become obsolete.
Then there's a capture risk.
Yeah.
The foundational promise of blockchain technology was to build a viable alternative to the existing financial establishment.
Yeah, that was the whole point.
If the XRPL validator list is essentially handed over entirely to central banks and Wall Street consortiums, you haven't built an alternative system. You've simply built a highly efficient digital version of the exact same dollar-dominated order we live under today.
Furthermore, as long as Ripple and the XRPL Foundation retain the power to publish the default validator list, they act as the ultimate gatekeepers. The essay refers to this specific dynamic as an absolute monarchy with empty chairs.
But I feel like the sharpest objection, the one that really challenges the core logic of this institutional takeover, comes from the open source nature of the code itself. The code for the XRP Ledger is public. Anyone can view it, copy it, and deploy it. If central banks look at this 80% treaty architecture and decide it's perfect for their needs, why wouldn't they just copy and paste the code, spin up their own private sovereign network with their own selected validators, and completely abandon Ripple and the public XRPL?
It is the ultimate vulnerability for any open source project. Why deal with a public network when you can control a private clone?
It's exactly.
But Janus provides a compelling counter-argument based on what he calls the liquidity trap.
Okay, what is that?
A central bank can effortlessly fork the open source software, but software is only half the equation in cross-border finance.
What's the half they can't copy?
They cannot copy the deep, neutral liquidity. Specifically, they cannot clone the billions of dollars of retail XRP floating in the public open market.
Ah, I see.
Let's trace how a bridge asset actually functions. Imagine a regional bank in Mexico needs to pay a supplier in Japan at 3 a.m. on a Saturday.
When traditional correspondent banks are closed.
Exactly. On the XRPL, that Mexican bank can take pesos, instantly swap them for XRP on the open market, send the XRP across the ledger in 3 seconds, and instantly sell that XRP for Japanese yen on the other side.
But to execute that swap at 3:80 a.m. for a $50 million transaction without suffering massive price slippage, there has to be a massive active pool of buyers and sellers constantly trading the asset.
Exactly. Without that continuous public float, a sovereign fork of the code is, as the author writes, just a database with a voting ritual attached.
Well, that's a great line.
It possesses the technical speed, but it lacks the economic utility to actually bridge value between two obscure currencies. The retail XRP market, the volatile public trading environment that traditional banks usually despise, is the exact mechanism that makes the cross-border settlement function possible. You cannot utilize the clean, efficient code without relying on the messy public liquidity pool to act as your bridge.
That brings us out of the realm of theory and into the timeline of reality. Because this transition isn't an abstract concept, it is allegedly happening right now.
It is.
And this is where the subscriber comment from William Lawley provides crucial perspective.
Lawley points out that this structural view of the network completely vaporizes the usual narrative dominating the retail crypto space.
Because for years, the conversation has been driven by hype, right? Influencers pointing to technical price charts or chasing rumors of bank partnerships.
Yeah, exactly. Lawley notes that Janus's thesis proves that real systemic adoption isn't about retail hype cycles. It is purely architectural. It fundamentally comes down to who physically controls those validator seeds.
And Janus holds himself strictly accountable to a verifiable timeline. He points back to that McKinsey analysis, noting that the interoperability war is happening right now, with a critical window closing between 2026 and 2027.
Yes, he offers a falsification test for his entire theory. He states that if we reach the end of 2027, and the walled gardens like Canton have successfully captured the multi-trillion-dollar volume of tokenized deposits, and the XRPL validator list is still populated merely by universities and independent engineers.
Then what?
Then he admits his theory was wrong. The institutional treaty body was a phantom.
It would just be a dead end with good acoustics.
Pretty much.
If the mega institutions don't formally request their seats and begin governing the network by the end of that window, the United Nations of liquidity theory collapses. The beautiful embassy stays empty forever.
So what does this all mean for the broader financial landscape?
So what does this all mean? It means the invisible plumbing that dictates how global commerce functions is being completely rebuilt beneath our feet as we speak.
Yeah, it really is.
The central banks and the mega corporations are running out of time to make a foundational choice. Do they retreat into a permissioned walled garden like Canton, where they have to place their trust in a private Wall Street consortium?
Or do they build isolated islands using the Cosmos model, hoping they can eventually engineer a bridge asset later?
Exactly. Or do they walk into that empty embassy, claim their pre-allocated seats on the XRPL, and accept an 80% treaty system where nobody has absolute control, but everyone holds a veto?
It is a phenomenal geopolitical chess match, honestly, entirely disguised as a software architecture debate.
But before we wrap up today's deep dive, I want to leave you, the listener, with a final provocative thought that emerges from the mechanics we just discussed. We established that the only reason a central bank wouldn't simply copy the open source code to build their own private network is because they desperately require the deep, neutral liquidity provided by the retail XRP float. They need the everyday users who've been holding, trading, and providing market-making depth for years to make their massive cross-border swaps possible.
The everyday retail users are the ones who effectively bootstrap the network's value and utility.
But consider the endgame of this theory. If this network is ultimately destined to evolve into a multi-trillion-dollar institutional treaty body, governed exclusively by central banks and megacorporations who only act to protect their own sovereign interests.
Yeah.
What happens to those everyday retail users? The very people who provided the liquidity that made the network valuable to institutions in the first place. Do they get representation inside that embassy? Or, once the institutions finally take over the voting power, do those everyday users systematically get squeezed out of the very financial system their liquidity helped secure?
It really forces us to ask if the architects of the new financial system are simply using the public to lay the bricks, only to lock them out of the building the moment construction is finished.
Next time you picture that massive, flawless, state-of-the-art embassy, ask yourself, when the doors finally lock, who is actually left inside?